The ocean is one of Earth's last frontiers, a world that remains largely unexplored. Covering over 70% of the planet, the deep sea is a labyrinth of mysteries, stretching down to depths of nearly 36,000 feet. Think about that for a moment. While we have mapped the surface of Mars, we have only explored about 20% of our own oceans. This vastness is both daunting and exhilarating, as we consider what secrets still lie beneath the waves. Let's start with some staggering facts. Over 90% of the ocean is still unexplored and unmapped, which translates to more than 1 million cubic kilometers of water waiting to be discovered. Incredibly, this dark and cold realm is home to more organisms than we can even imagine. From bioluminescent jellyfish to colossal squids, these fascinating life forms have adapted to extreme environments where pressure is immense and sunlight never reaches. The journey into the depths truly began with the invention of submersible technology. In 1960, deep-sea explorers Jacques Piccard and Don Walsh made history by descending into the Mariana Trench, the deepest known part of the ocean, aboard the bathyscaphe Trieste. They reached a staggering depth of 35,814 feet, setting a record that stood for over 50 years. But what they found was far from an empty void. Instead, they encountered strange, unearthly creatures that seemed to defy the laws of biology. Imagine catching a glimpse of a giant jellyfish, pulsating in its fluorescent glow, or witnessing a fish with transparent skin that allows its internal organs to show. This was just the beginning of our awe-inspiring journey into the abyss. Since then, the development of more advanced submersibles like the DSV Alvin and the remotely operated vehicles, ROVs, have allowed scientists to peer deeper into the ocean, revealing astonishing biodiversity and ecosystems previously thought impossible. But the challenges are immense. The intense pressure at these depths, over 1,000 times what we experience on land, makes it difficult for humans to explore. Yet, technology keeps advancing. For instance, in 2019, the Deep-Sea Challenger made headlines when filmmaker James Cameron undertook a solo dive to the bottom of the Mariana Trench, capturing footage of life that had never been seen before. Imagine the thrill of discovering life forms that have been untouched by humankind for thousands, perhaps millions, of years. This exploration is not just about the thrill of discovery, it's also vital for understanding our planet's health. The ocean plays a crucial role in regulating our climate, and many of these deep-sea ecosystems are sensitive to changes brought on by climate change and human activity. As we venture deeper into this underwater wilderness, we begin to unravel not only the secrets of the ocean but also our interconnectedness with it. Every creature discovered is a piece of the puzzle that informs us about biodiversity, ecology, and the life-supporting systems of our planet. As we continue this exploration, we must ask ourselves, what will we find next? Join us as we delve deeper into the incredible discoveries that await beneath the ocean's surface. What if I told you that some of the most astonishing forms of life on our planet thrive in conditions that seem utterly alien? The deep sea is a unique ecosystem, home to creatures that seem almost mythical. Take, for instance, the anglerfish, a predator that lures its prey with a bioluminescent lure. This fish embodies the strange and often gruesome realities of survival in the deep, showcasing evolution's creativity in the face of extreme conditions. One of the most spectacular adaptations found in the deep is bioluminescence. This rare phenomenon allows organisms to produce light through biochemical reactions. Almost 90% of deep-sea animals are bioluminescent, using their glow for communication, predator evasion, or attracting prey. Scientists are still exploring how these creatures harness light and what advantages it gives them in the profound darkness of their environment. Consider the giant squid, once thought to be merely a seafaring myth. This leviathan can grow up to 43 feet long and is capable of hunting in depths where very few can survive, using its keen sense of sight to locate prey in dark waters. Our understanding of these creatures has evolved dramatically over the years, particularly after the first images of a live giant squid were captured in 2006. The footage sparked a tidal wave of interest in marine research and the mysteries still lurking in the ocean. But life in the deep is not just about bizarre adaptations, it also involves complex ecosystems. Hydrothermal vents, discovered in 1977, are like oases in the darkness. These underwater geysers release superheated, mineral-rich water, creating a nurturing environment for unique organisms, including tube worms and extremophiles. These creatures have no reliance on sunlight. Instead, they harness energy from the chemicals emitted by the vents, showcasing a form of life that challenges our traditional understanding of biological processes. Researchers have found entire ecosystems that thrive in extreme conditions, existing without the necessity of sunlight. This raises profound questions about the origins of life on Earth and even the potential for life in the universe. Are there other planets where similar conditions might allow life to flourish? The discoveries made in these underwater ecosystems not only help us understand our own planet but also provide insights into the potential for extraterrestrial life. For instance, Europa, one of Jupiter's moons, is believed to have a subsurface ocean. Could life exist there, thriving in the icy darkness like its terrestrial counterparts? As we further investigate the abyss, each revelation only deepens the mystery of how life adapts and thrives in seemingly inhospitable environments. As we embark on this thrilling journey, what other secrets of life will unveil before our eyes? The ocean is not only a realm of mystery but also a repository of invaluable resources. As we delve deeper into the ocean, we uncover a wealth of materials that could potentially revolutionize industries and improve our quality of life. From pharmaceuticals derived from marine compounds to minerals used in technology, these hidden treasures are becoming increasingly important as terrestrial resources dwindle. One of the most promising areas of research lies in marine biotechnology. Scientists are discovering that many organisms have evolved unique compounds that hold the key to breakthroughs in medicine. For instance, the cone snail possesses venom with potent analgesic properties. This venom has led to the development of a new class of painkillers that may be more effective than traditional opioids but without the addictive side effects. Furthermore, coral reefs, often referred to as the ocean's rainforests, are a hotspot for biodiversity and a source of potential medical breakthroughs. Compounds found in various coral species have shown promise in the treatment of cancer and other diseases, yet these precious ecosystems are under severe threat from climate change and pollution. Protecting these reefs is not merely an environmental issue, it's a matter of public health and future wellness. Additionally, the ocean floor is rich in minerals such as rare earth metals. As demand for electronics increases, industries are looking to the ocean for new sources of these critical materials. Seafloor mining has become a heated topic, with proponents arguing for its potential economic benefits while opponents warn of devastating impacts on marine ecosystems. The debate around mining the ocean is complex. Proponents argue that extracting these resources can reduce dependence on land-based supplies and lead to advancements in technology. However, studies show that the disturbance caused by mining can irreparably damage sensitive habitats. As we weigh the benefits and consequences, we must consider, is it worth jeopardizing an entire ecosystem for short-term gain? As we investigate these resources, we find ourselves at a crossroads. The balance between exploration and conservation poses a significant challenge. What will we decide as stewards of this planet? As we continue our exploration, let's ponder what treasures we might uncover, and more importantly, what sacrifices we are willing to make to secure our future. Climate change has been described as one of the greatest threats to ocean health and by extension, our own existence. The consequences are unfolding before our eyes as ocean temperatures rise, sea levels increase, and ecosystems transform. These changes are not just environmental, they impact our economies, societies, and even political stability. A striking example is the coral bleaching phenomenon caused by rising sea temperatures. When corals become stressed due to temperature fluctuations, they expel the symbiotic algae that provide them with food and color. This process leads to a stark white appearance and, ultimately, death if conditions do not improve. Research indicates that approximately 50% of the world's coral reefs have died in the last 30 years. Coral reefs are vital to marine biodiversity, housing over 1 million species, and their loss threatens the entire oceanic ecosystem. In addition, ocean acidification, a direct result of increased carbon dioxide levels in the atmosphere, poses a significant danger to marine life. As CO2 levels rise, oceans absorb more of it, leading to a decrease in pH levels. This chemical change affects shellfish, corals, and other calcifying organisms, disrupting their ability to form shells and skeletons. The implications for marine food webs and human food supply chains are dire, as many communities rely on fish and shellfish as primary protein sources. Further complicating this issue is the effect of melting polar ice caps. The loss of ice alters ocean circulation patterns, which can impact weather systems globally. Recent models predict that we may face more extreme weather events due to these changes. Vulnerable populations, particularly those in low-lying coastal areas, face existential threats as sea levels rise and storms intensify. Yet, amidst these challenges, there is a growing movement advocating for ocean conservation. Organizations worldwide are uniting to protect marine ecosystems. Governments are beginning to establish marine protected areas, aiming to safeguard vital habitats and allow ecosystems to recover. Through education, advocacy, and community involvement, we can combat the impacts of climate change on our oceans. The question remains, can we act swiftly enough to reverse the damage? The future of our oceans and ourselves hangs in the balance as we journey deeper into this crisis. What actions will we take to create a more sustainable world? As we explore the depths of knowledge, let's consider the role we play as stewards of the ocean. Every small action can contribute to lasting change. As we look toward the future, the potential for ocean exploration is limitless. Technological advancements are paving the way for a new age of discovery, one where we can explore deeper, faster, and with greater precision than ever before. But what does this mean for the future of our oceans? The rise of autonomous underwater vehicles, AUVs, and advanced remotely operated vehicles, ROVs, has transformed the way we conduct marine research. These vehicles are equipped with cutting-edge technology, including sensors, cameras, and data collection tools, allowing scientists to gather unprecedented amounts of data. For instance, scientists recently used AUVs to map the seafloor in real time, revealing underwater features previously hidden from view. This evolution in technology also allows us to collect samples and data from regions that were once inaccessible or too dangerous for human divers. The application of machine learning and artificial intelligence further enhances our ability to analyze and interpret this vast data. As we harness these technologies, we are entering a new era of marine science that blurs the lines between exploration and conservation. Another exciting frontier lies in collaboration. International partnerships among governments, research institutions, and private companies are becoming more common, allowing for shared resources and expertise. Such collaborations can lead to concerted efforts in marine conservation and resource management. But as we advance, we must remember the ethical implications of our discoveries. The deep sea is not just a resource to be exploited, it's a delicate ecosystem worth protecting. As we uncover new knowledge, we must tread carefully, ensuring that exploration doesn't lead to degradation. Ethical considerations should guide our actions, reminding us that our mission is not only to discover but also to preserve. The future of ocean exploration is bright, filled with possibilities. What marvels lie ahead? What discoveries are waiting to be made? With every dive into the deep, we are challenged to rethink our relationship with the ocean. It holds keys to understanding not just our planet but the universe as a whole. In this shared journey of discovery, let us move forward responsibly, ensuring that the lessons learned from the deep resonate throughout generations to come. What will be your role in this unfolding journey? As we plunge deeper into the ocean's depths, the tools we use to explore this enigmatic realm have evolved dramatically over the years. From the early days of simple diving bells to the cutting-edge technology of today, innovations in ocean exploration technology have expanded our horizons and enhanced our understanding of this vast blue frontier. In the late 1800s, the invention of the bathyscaphe, a free-diving submersible vessel, marked a pivotal moment in ocean exploration. Designed by Auguste Piccard, this remarkable machine allowed human beings to descend into the depths of the ocean, reaching astonishing depths of over 10,000 meters. Piccard's pioneering journey in 1960 set the stage for future explorations, showcasing the potential of human ingenuity. But technology has only advanced from there. Fast forward to the present day, we now have remotely operated vehicles, or ROVs, capable of diving into the darkest parts of the ocean while transmitting real-time data back to researchers on the surface. ROVs like the Jason and the Hercules are equipped with high-definition cameras and scientific instruments, allowing scientists to safely explore underwater volcanoes and hydrothermal vents without jeopardizing human lives. In 2012, the ROV called Nereus became the first vehicle to reach the deepest trench on Earth, the Mariana Trench, demonstrating how far we've come in our quest for knowledge. But it is not only ROVs that are transforming our exploration methods. Autonomous underwater vehicles, or AUVs, have emerged as game changers. These unmanned crafts can operate independently for extended periods, mapping the seafloor and collecting vital data on temperature, salinity, and marine life, information crucial for understanding climate change and ocean circulation patterns. One groundbreaking project, the Seabed 2030 initiative, aims to map the entire ocean floor by 2030 using a combination of AUVs, satellite data, and contributions from both governmental and academic organizations globally. As of today, over 20% of the ocean floor has been mapped, revealing important geological features and potentially valuable resources. The use of artificial intelligence in analyzing data collected from these vehicles is also forging a new path. AI algorithms help identify species and analyze trends in the data that would otherwise remain unnoticed in the sheer amount of information gathered. For instance, researchers have developed AI systems capable of recognizing the calls of different whale species in real time, providing insights into their behavior and migration patterns. This technology not only aids in conservation efforts but also enriches our understanding of these majestic creatures. The integration of 3D printing technology in creating submersibles has also cut costs and streamlined design processes. Imagine being able to fabricate components for underwater devices right on the ship, reducing the time and cost associated with deep-sea research expeditions. As exploration continues, the ocean becomes less of a mystery and more of a realm we can navigate. These technological advancements not only allow us to reach new depths but also help us study and understand the implications of our actions on ocean health. Innovations in ocean tech are paving the way for new discoveries, raising questions about what lies ahead. What revolutionary discoveries await us as we harness the power of technology to explore the unknown? Only time will tell. Despite the advancements in our exploration technologies, the ocean remains one of the last great mysteries on Earth. Roughly 80% of the ocean is still unexplored and uncharted. With every dive into its depths, scientists encounter phenomena that challenge our understanding of the natural world. Take the phenomenon known as the Bermuda Triangle, for instance, a region where ships and planes have mysteriously vanished without explanation. Some theories abound, ranging from magnetic anomalies to methane hydrate eruptions, but there is no definitive answer. This air of mystery extends to the depths of hydrothermal vents, where scientists have discovered unique ecosystems thriving in extreme conditions. These vents spew superheated, mineral-rich water from the Earth's crust, creating an environment that teems with life without any sunlight. The organisms found here, like the giant tubeworm, rely on chemosynthesis rather than photosynthesis, making them entirely dependent on these underwater geysers. How such life forms evolved, and what other organisms may exist in similarly extreme conditions throughout the ocean, remains an intriguing question. In 2019, researchers discovered a new species thriving at these depths that appeared to exhibit bioluminescence, a trait thought to be rare among deep-sea creatures. This suggests that our understanding of life in extreme environments is still evolving. Moreover, the ocean floor hides geological formations that could rewrite Earth's history. Take, for example, the underwater mountain ranges over 80,000 kilometers long, known as mid-ocean ridges. These ridges, formed by tectonic plate movements, are still not fully understood. Some scientists believe they may hold clues to our planet's past climate and geological changes. What exactly can these underwater mountains teach us about Earth's formation? And what about the ocean's vast biodiversity? The ocean is home to an estimated 230,000 known species, yet scientific estimates suggest that over 2 million species may exist in total, most of which remain undiscovered. For instance, the recent findings of unique species in the Mariana Trench, including the snailfish, push the boundaries of our understanding of adaptation and evolution in extreme environments. Each expedition to these depths unveils more questions than answers, creating a sense of urgency to explore and learn before it is too late. As climate change accelerates and human activity encroaches ever closer to marine ecosystems, the race against time to uncover the mysteries of the ocean intensifies. How many secrets can the deep hold, and what can they reveal about our planet and ourselves? As we set out to solve these enigmas, we find ourselves at a crossroads between discovery and conservation. Will we prioritize the health of the ocean while seeking to understand it more deeply? The answers await us in the dark corners of this blue universe. The ocean is not merely a collection of water, it is a fundamental component of our planet's ecosystem. It regulates climate, supports diverse life forms, and provides essential resources for billions of people. As we explore the ocean, it's crucial to understand the vital role it plays in maintaining the balance of life on Earth. Approximately 50% of the oxygen we breathe is produced by phytoplankton, microscopic organisms that thrive in the sun-drenched surface waters of the ocean. These tiny powerhouses are integral to the carbon cycle and act as a natural buffer against climate change. When carbon dioxide levels rise in the atmosphere, the ocean absorbs a substantial amount, reducing the impact of greenhouse gases. However, this absorption comes at a cost, leading to ocean acidification, which threatens coral reefs and marine life. Coral reefs, often dubbed the rainforests of the sea, support over 25% of all marine species despite covering only 0.1% of the ocean's surface. Their health is a reflection of oceanic conditions. When we witness coral bleaching, it signals a serious warning about the overall health of marine ecosystems. The decline of reefs not only jeopardizes marine biodiversity but also impacts the livelihoods of millions who depend on fishing and tourism. Furthermore, the ocean also plays a crucial role in weather patterns. The warm waters of the ocean help drive global temperature regulation, influencing everything from storm formation to rainfall patterns. For example, the El Niño phenomenon, an oceanic and atmospheric interaction, affects weather globally, from droughts in Indonesia to floods in South America. As ocean temperatures rise due to climate change, the frequency and intensity of such events may increase. This creates a ripple effect, jeopardizing food security, health, and economies worldwide. Not to forget, the ocean is an essential source of food for billions. Fisheries provide direct sustenance and livelihoods, with over 3 billion people relying on the ocean for their protein intake. Sustainable fishing practices are vital to ensure we don't overexploit these resources. With incidents of illegal fishing and overfishing, the balance of marine life is threatened. Initiatives promoting sustainable fishing methods, such as catch shares and aquaculture, are essential to maintaining marine ecosystems. In this intricate web of life, the ocean is a central player, influencing not just marine life but all life on Earth. The interconnectedness of our ecosystems means that changes in the ocean have profound effects on land and air. As stewards of this planet, it is our responsibility to protect the oceans for future generations. Understanding the role of the ocean in global ecosystems is vital to addressing climate change and conserving our natural world. What steps can we take to ensure the vitality of the ocean and its resources as we move forward? The answers lie in our collective actions and choices. The ocean is not just an expansive body of water, it is a powerful source of cultural identity and inspiration for countless societies around the globe. From ancient civilizations that revered the sea to modern communities that rely on it for their livelihoods, the ocean holds a significant place in human history and culture. Many indigenous peoples view the ocean as a living entity, integral to their way of life and traditions. For example, the Maori of New Zealand celebrate their ancestral connection to the sea through stories and rituals, epitomizing their respect for marine ecosystems. The ocean serves as a backdrop for art, literature, and music. Countless works have been inspired by its beauty and mystery, from Homer's Odyssey to contemporary films like Finding Nemo. These creations reflect our fascination with the ocean's vastness and the creatures that inhabit it. The ocean's beauty has galvanized movements for conservation and environmental awareness. Art installations like the Ocean Cleanup and Ghost Nets bring attention to the issue of plastic pollution, uniting communities to fight for a cleaner ocean. Moreover, the ocean's resources contribute to various cultural practices, including fishing traditions, culinary arts, and festivals celebrating marine harvests. For example, the annual Cooper's Hill Cheese Rolling Festival in England, while seemingly eccentric, underscores the connection between local communities and their historical ties to farming and fishing. As we navigate the complexities of our relationship with the ocean, the cultures that have emerged around it demonstrate both a reverence for its gifts and an awareness of the threats it faces. The cultural significance of the ocean also extends to its role in the economy through tourism. Coastal tourism generates billions of dollars each year, emphasizing the need for sustainable practices to protect ocean health. With climate change threatening coastal ecosystems, the cultural fabric woven around the ocean faces unprecedented challenges. The potential loss of marine biodiversity and habitats may result in the erosion of cultural identities tied to the sea. As we appreciate the ocean's cultural dimensions, we must ask ourselves how we can preserve this heritage while promoting sustainable practices. The ocean is indeed a source of wonder, inspiration, and a vital part of our human story. How do we ensure the stories of the ocean continue to be told for generations to come? The answer might lie in education, conservation, and the synergistic efforts of communities worldwide. As we wrap up our exploration of the deep ocean, it's becoming increasingly evident that we stand at a crucial juncture in our relationship with this vast and vital resource. The future of our oceans, and, by extension, the planet, depends on our collective commitment to conservation efforts. The ocean covers over 70% of the Earth's surface, and its health is directly tied to the well-being of all life on Earth. With the current pace of climate change, overfishing, and pollution, the ocean is facing unprecedented challenges. We must act now to mitigate these threats. Marine Protected Areas, or MPAs, are one of the most effective tools for conserving ocean ecosystems. These designated regions help to protect critical habitats, allowing marine life to flourish and recover from human-induced stressors. In 2010, the world adopted the Aichi biodiversity targets at the Convention on Biological Diversity, committing to protect 10% of coastal and marine areas by 2020. Though we fell short of that goal, the urgency remains greater than ever. As of 2021, only about 7.5% of the ocean is protected. Yet, initiatives like the High Seas Treaty, finalized in 2023, aim to establish a comprehensive framework for protecting biodiversity on the high seas, which cover nearly half of the ocean. This treaty represents a significant step towards global collaboration in ocean conservation. Local and indigenous communities are also vital in these efforts, often having traditional knowledge that can inform and enhance conservation strategies. Empowering these communities ensures that conservation efforts are culturally sensitive and effective. International collaboration is essential. The ocean doesn't recognize geopolitical boundaries. It requires unified action to address global issues like plastic pollution, which is becoming a dire threat to marine life. The Ellen MacArthur Foundation's commitment to creating a circular economy has sparked innovative solutions to eliminate plastic waste and promote sustainable materials. Making a shift towards a circular economy could significantly alleviate the burden of plastic in our oceans. As individual citizens, our choices matter. Simple actions, such as reducing plastic usage, supporting sustainable seafood, and spreading awareness can contribute to the collective effort. Educational initiatives, especially for younger generations, will empower people to become stewards of the ocean. Programs that teach marine science in schools can foster a lifelong connection and responsibility to protect ocean health. In this age of technology, we can leverage data and AI to enhance conservation strategies and monitor the health of ocean ecosystems. Innovative apps and platforms allow citizens to report pollution and track wildlife, empowering local communities in conservation efforts. Looking ahead, the future of the ocean rests on our shoulders. By integrating science, technology, and community engagement, we can ensure that the ocean not only survives but thrives for generations to come. How will we respond to the challenges ahead? The answer lies within each of us, our choices, our actions, and our commitment to preserving the wonders of the deep ocean. Together, we can forge a new path towards a healthier ocean and a more sustainable planet, ensuring that the mysteries of the deep continue to inspire and nurture future generations. This is just the beginning of our journey into the blue unknown. The deep sea is not just a dark, desolate abyss. It is a thriving ecosystem filled with life that exhibits unimaginable resilience. From hydrothermal vents that spew superheated water rich in minerals to cold seeps that release methane, these environments are home to some of the most remarkable organisms on the planet. Imagine creatures that can withstand crushing pressures and complete darkness, such as the giant tubeworm and the elusive anglerfish. The discovery of these unique adaptations offers critical insights into the resilience of life. In fact, scientists have documented over 2,000 species thriving around hydrothermal vents alone. These vents serve as oases of life, supporting diverse communities that rely on chemosynthesis rather than photosynthesis. One fascinating case study involves the discovery of the deep-sea coral gardens near the coast of the Bahamas. Researchers found corals thriving at depths of over 1,500 feet, where sunlight never penetrates. This discovery reshapes our understanding of coral biology and its potential for future research, especially concerning climate change's impact on these ecosystems. The resilience of these ecosystems is put to the test in light of human impacts. Oil drilling, deep-sea mining, and pollution threaten these fragile environments. The urgency to protect these ecosystems cannot be overstated. As we delve deeper, understanding their ecology becomes crucial for conservation and sustainable practices. The ocean remains one of the least explored frontiers on Earth, hiding an abundance of undiscovered species. Every expedition brings new surprises. In 2016, researchers on an 8-week journey to the Mariana Trench discovered more than 200 new species, including various types of jellyfish, crustaceans, and even a unique type of snailfish. With current estimates suggesting that up to 2 million species could remain undiscovered, every dive ignites excitement amongst scientists. Many of these unknown creatures possess unique biochemical properties that have vast implications for medicine and biotechnology. For example, the deep-sea snailfish discovered in 2017 produces antifreeze proteins that prevent ice crystals from damaging its cells, raising possibilities for medical applications in organ preservation and cryopreservation. As exploration technology advances, it becomes increasingly feasible to document these unknown species. Remote-operated vehicles and advanced submersibles equipped with cameras allow researchers to visually document and study these creatures in their natural habitats. This thrilling realm of unknown biodiversity not only expands our understanding of life on Earth but also reveals the interconnectedness of various ecosystems, reminding us that every organism plays a vital role in our planet's health. The question remains, how many more secrets does the ocean hide beneath its surface, waiting for us to unveil them? The answer beckons us to explore more, to protect and preserve the depth of life that continues to inspire and amaze us. As the world seeks new resources to fuel its appetite for technology, the depths of the ocean have become an enticing target for extraction. The allure of rare earth metals, precious minerals, and polymetallic nodules lying on the ocean floor has led to a surge in interest in deep-sea mining. But this burgeoning industry poses significant ethical questions. The international community faces a monumental challenge. How do we balance the need for resources with the preservation of marine ecosystems? A notable example lies in the Clarion-Clipperton Zone, an area in the Pacific Ocean that holds an estimated 27 billion metric tons of polymetallic nodules. These nodules are rich in essential minerals like cobalt, nickel, and copper, crucial for modern technologies, from smartphones to electric vehicles. However, as companies begin to explore and mine these resources, scientists warn of the dire consequences for delicate ocean ecosystems. Disruption of the seabed could lead to irreversible damage, wiping out countless species before we even comprehend the full extent of oceanic biodiversity. The 2019 International Seabed Authority (ASA) meeting raised concerns that the current guidelines for deep-sea mining are inadequate to protect marine life. How do we govern an area that is both a high seas commons and a treasure trove of potential resources? A particularly alarming case involves a 2021 incident where a mining company conducted exploration off the coast of Mexico, resulting in significant habitat destruction. Marine biologists observed a drop in local biodiversity, and communities dependent on these ecosystems reported drastic changes in fish populations. This incident highlights the urgent need for a framework that prioritizes ocean health alongside resource extraction. Critics argue for a precautionary principle, prioritizing conservation over exploitation until we fully understand the ecosystems at play. The ocean deserves respect, and species like the fragile deep-sea coral forests, known for their role in carbon storage, must be protected. It's a moral imperative to consider the future of our oceans when weighing economic gain against environmental loss. Advocating for the ocean's protection goes beyond policy change, it encompasses community engagement. Local populations play a pivotal role in conservation efforts. Collaborative initiatives where fishermen and scientists work together can lead to improved practices that ensure sustainable use of marine resources. In the Caribbean, for instance, local fishermen have taken the lead in protecting coral reefs by implementing no-fishing zones to allow ecosystems to rebound. By involving communities in decision-making, conservation efforts become more effective and foster a sense of ownership over the marine environment. Education initiatives have also put ocean conservation on the map, increasing global awareness about the challenges faced by marine ecosystems. Programs encouraging children to engage with ocean science inspire the next generation of ocean advocates. Through hands-on experiences, such as beach cleanups and marine research projects, young people become stewards of the ocean, instilling a deep respect for its wonders. The collective responsibility to protect the oceans should unite us in addressing the complex challenges facing our blue planet. The future of deep-sea mining continues to be a contentious issue, inviting passionate discussion about where we draw the line between treasure and tragedy. As we forge ahead in the quest for resources, our approach will determine not just the fate of the ocean but also the legacy we leave for future generations. The quest to explore the hidden depths of our oceans is not just a challenge, it's an adventure fueled by technology. As we strive to uncover the secrets of the deep sea, technological advancements have transformed the way we approach underwater exploration. In the past, exploration was limited by human capability and the constraints of early submersibles. Fast forward to today, and we've equipped ourselves with next-generation technology capable of withstanding the immense pressures of the ocean's depths. Underwater robots and autonomous vehicles have revolutionized our understanding of the ocean floor. For instance, the remotely operated vehicle, ROV, Alvin has been instrumental in countless discoveries, including the famed Titanic wreck. Equipped with high-definition cameras and scientific instruments, these vehicles allow researchers to gather data and document life in the abyss without ever setting foot in the water themselves. In fact, Alvin has made more than 5,000 dives, revealing countless marine wonders and giving researchers access to previously unreachable environments. Moreover, advancements in sonar technology have enabled scientists to map the ocean floor with unprecedented detail. Multi-beam sonar systems can create three-dimensional images of underwater landscapes, uncovering features like seamounts, trenches, and underwater volcanoes. During a 2018 expedition, researchers used sonar technology to discover a hidden underwater mountain range in the Indian Ocean, sparking excitement about the potential for undiscovered marine species that may reside nearby. One of the most astonishing innovations comes from the field of artificial intelligence. Researchers are now using AI to identify species in real time. This technology analyzes images captured by underwater cameras, promptly distinguishing between various marine organisms. Not only does this accelerate research, but it also provides a vital tool for monitoring biodiversities, such as tracking endangered species and understanding their habitats more effectively. Despite these advancements, the challenges of deep ocean exploration remain daunting. The depths of the ocean also hide dangers, including extreme temperatures, corrosive environments, and limited visibility. A key example is the 2021 expedition led by the Schmidt Ocean Institute, where researchers faced equipment failures during their dive, underscoring the perils of ocean exploration. Yet, resilient teams continued to push the boundaries of what is possible, demonstrating an unwavering commitment to uncovering the ocean's mysteries. As we look to the future, the question remains, how can we combine technology and conservation in a way that maximizes exploration while protecting marine ecosystems? New tools like environmental DNA, EDNA, sampling allow scientists to collect samples from ocean water and analyze them for genetic material shed by organisms. This innovative technique opens up avenues for monitoring biodiversity without intrusive sampling methods that could disrupt marine habitats. The collaboration between technologists, marine scientists, and conservationists will be crucial in shaping a sustainable path forward in ocean exploration. To fully comprehend the complexities of ocean systems, interdisciplinary approaches to research are essential. Collaboration between oceanographers, biologists, geologists, and climate scientists can yield critical insights into the ocean's role in global climate systems. For example, the Ocean Observatory Initiative, supported by several institutions across the globe, integrates data from a network of underwater sensors to study ocean conditions and their impact on climate change. Through detailed data analysis, researchers can observe trends in ocean temperature, salinity, and nutrient composition, contributing to climate modeling efforts and predicting future scenarios. Moreover, the blending of humanities with science can illuminate the cultural significance of the ocean. By integrating indigenous knowledge systems into modern research, scientists can develop a holistic understanding of marine resources and their historical contexts. Indigenous communities possess invaluable knowledge about sustainable practices, passed down through generations. A partnership between Western science and indigenous wisdom could forge a path toward more effective resource management and foster respect for the ocean. As we navigate the uncharted waters of exploration, embracing interdisciplinary collaboration becomes paramount. The ocean is not just a resource, it's a complex system interwoven with human existence. The future holds infinite possibilities for discoveries that could reshape our understanding of life on Earth, but it requires a collective commitment to exploration, preservation, and respect for our blue planet. The ocean's depths host bizarre and awe-inspiring life forms that challenge our understanding of biology and evolution. Imagine a creature that can produce its own light in the pitch-black abyss. This is the world of bioluminescence. Among the strangest of these creatures is the anglerfish, known for its unique method of hunting. The female anglerfish dangles a bioluminescent lure that attracts prey, revealing a complex relationship between survival and adaptation in these dark environments. Recent discoveries in the Mariana Trench revealed not just anglerfish but also the ghostly jellyfish known as the deepsteria. With its massive, translucent bell and trailing tentacles, the deepsteria drifts gracefully through the dark waters, captivating scientists and researchers alike. Among the discoveries made during oceanic expeditions, the giant squid remains one of the most compelling. For centuries, sailors spoke of enormous sea creatures, often dismissing them as myths. However, in 2006, researchers captured the first-ever footage of a living giant squid in its natural habitat. This colossal being, with eyes the size of basketballs, challenges our preconceived notions of what life looks like in the deep. Such astonishing creatures remind us that the deep ocean is not just a barren wasteland but a flourishing habitat filled with life forms capable of incredible adaptations. One of the more enigmatic beings discovered in the depths is the deep-sea octopus, known for its intelligence and ability to camouflage. Researchers studying the octopus behaviors have found that these creatures can manipulate their color and texture, blending into their surroundings to evade predators. This remarkable ability puts forth the question, what other secrets lie in the depths, waiting to be uncovered? The hunt for new species continues, with estimations suggesting that we've only explored about 20% of the ocean's depths. This lack of exploration leaves us blind to the myriad of creatures that could exist. The ocean continues to be an area of great intrigue and wonder, prompting more research and curiosity. As we advance our technology and delve deeper into the mysterious waters, we uncover new life forms that reveal the astonishing capabilities of evolution and adaptation. As we ponder on the mysteries of the deep ocean, we must also consider the health of these ecosystems. Every discovery we make unveils the delicate balance that sustains life below the surface. Most importantly, how our actions above the surface impact these otherworldly realms. Each new life form found expands our understanding of biodiversity and its significance to planetary health, pushing the limits of our imagination. What other secrets will the ocean reveal in the years to come? The quest to uncover the unknown continues. The ocean floor is a treasure trove of geological wonders that tell the story of our planet's history. Among these wonders is the Mid-Atlantic Ridge, the longest mountain range in the world. Stretching over 10,000 miles, this underwater mountain range is a hotspot of geological activity. It is formed by tectonic plates pulling apart, creating new oceanic crust as magma rises from the mantle. This process not only shapes the landscape but also plays a crucial role in regulating Earth's climate by sequestering carbon dioxide. Moreover, hydrothermal vents located along the mid-Atlantic ridge are one of the most astonishing discoveries in ocean geology. Discovered in the late 1970s, these vents spew superheated, mineral-rich water into the ocean, creating unique ecosystems that thrive in complete darkness. Organisms like tube worms, which can reach lengths of over 3 feet, rely on symbiotic bacteria to convert the chemicals from these vents into energy through chemosynthesis. This process forms the basis of a thriving ecosystem, despite being hundreds of miles away from sunlight. The discovery of these vents not only expanded our understanding of life but also led to advancements in technology and scientific thought. Researchers are now able to study the extreme conditions of these environments and gain insights into possible extraterrestrial life on moons like Europa and Enceladus, which have similar conditions. Could life exist elsewhere in the solar system? This question propels scientists into the ocean's depths daily, as they seek to unlock nature's secrets. The ocean floor is also adorned with underwater canyons and trenches that tell the story of Earth's past. The Mariana Trench, the deepest point in the ocean at nearly 36,000 feet, is a prime example. The trench has been shaped by immense pressure and tectonic activity, forming a unique ecosystem that serves as a time capsule of ancient Earth. Understanding these geological wonders is crucial, not only for scientific discovery but also for our understanding of Earth's future. The ocean floor acts as a major player in climate regulation, carbon storage, and the carbon cycle itself. For instance, studies show that sediments on the ocean floor can lock away carbon for thousands of years, a critical process in combating climate change. The delicate balance of these ecosystems and geological features emphasizes the need for their protection. As technology evolves, we must tread carefully in our exploration, ensuring we conserve these natural wonders for future generations. The ocean and its geological formations hold clues to our planet's history, and perhaps the keys to our future. As the world becomes more reliant on technology, the quest for resources in the deep ocean intensifies, leading to significant debates surrounding deep-sea mining. Rich deposits of minerals, metals, and rare earth elements lie beneath the ocean floor, prompting companies to eye these resources for commercial exploitation. Polymetallic nodules, for example, are potato-sized lumps of metals found on the ocean floor, rich in nickel, cobalt, and rare earth elements essential for high-tech devices. The International Seabed Authority estimates that the Pacific Ocean could hold billions of tons of these nodules, leading to significant interest from mining corporations. This potential goldmine brings forth the dilemma: can we responsibly exploit these resources without damaging the delicate ecosystems? Opponents of deep-sea mining argue that the ecological impact could be catastrophic. For instance, mining operations could devastate habitats that have taken millions of years to develop. The plumes of sediment created during mining may smother delicate organisms, disrupting entire food chains. To highlight this, we can look at past cases where similar activities have led to long-term ecological damage, such as the legacy of land-based mining operations. Moreover, the deep-sea environment is poorly understood, and the potential for undiscovered species being pushed to extinction as a result of mining is high. Marine biologists estimate that some species living in these depths may not be found anywhere else on Earth. The loss of these unique organisms could diminish our understanding of biology and the potential uses of marine biotechnology. As the debate continues, some countries have called for precautionary measures and moratoriums on deep-sea mining until better regulations and environmental impact assessments are established. The potential of the deep ocean for scientific and technological advancement cannot be overlooked, but it must be balanced with sustainable practices that ensure the ocean's health. To confront these challenges, innovative solutions are being developed. Some companies are investing in robotics and artificial intelligence to minimize the environmental footprint of resource extraction. This evolving technology presents a glimmer of hope for those advocating for both advancement and preservation. Yet, the question remains, will humanity prioritize short-term gains over long-term sustainability? As we navigate this complex landscape of deep-sea mining, we must remain vigilant about the consequences of our actions and consider the legacy we leave for future generations. The ocean remains our planet's final frontier, and it is our responsibility to protect its mysteries for the benefit of all life on Earth. Unlike the serene surface world, the ocean depths resonate with sounds that can travel thousands of miles. As we dive deeper, we discover an orchestra of the marine world, where the songs of whales, the clicks of dolphins, and the mysterious calls of unseen creatures create a symphony of communication and survival. These acoustic patterns, recorded using sophisticated hydrophones, reveal the complex social structures of marine species. For instance, studies show that humpback whales have distinct song patterns that change significantly over time, akin to human musical trends. Researchers like Dr. Ellen Garland from the University of Queensland have been analyzing these songs and found that they serve not just to attract mates, but to communicate with other whales over vast distances. Understanding these sounds also aids in conservation efforts, as they can indicate the health of marine populations. However, the increasing noise pollution from ships, drilling, and other human activities poses a threat to these delicate communications. With deep-sea habitats being disrupted, we must question how we can balance our needs with the essential life sounds of the ocean. Will we listen in time to protect these vital creatures and their environments? Deep in the ocean, near tectonic plate boundaries, we find hydrothermal vents that spew superheated water laden with minerals. These underwater geysers were discovered in 1977, revealing a completely new ecosystem thriving in complete darkness. Organisms here, like giant tubeworms and chemosynthetic bacteria, draw energy not from the sun, but from the chemicals released by the vents. The unique symbiosis between these microbes and larger organisms, such as the massive tubeworms, shows us nature's incredible adaptability. For instance, the Riftia pachyptila, a giant tubeworm, can grow up to 3 meters long and possesses a specialized organ called a trophosome that houses bacteria capable of converting sulfur and other chemicals into energy. This process, known as chemosynthesis, allows entire communities of life to thrive where sunlight never reaches. The discovery of these ecosystems has profound implications. It challenges our understanding of biological life and could give insights into the origins of life on Earth and potentially elsewhere in the universe. Yet, these delicate ecosystems are at risk from deep-sea mining and climate change. As we uncover more secrets, we must grapple with the question, should we exploit or protect these underwater treasures? As scientists explore the ocean depths, they uncover not just creatures, but potential cures. The burgeoning field of marine bioprospecting focuses on discovering new medicines derived from marine organisms. From sponges to seaweeds, these organisms have adapted to survive in extreme conditions, leading to unique biochemical properties. For example, the sea hare possesses a chemical called aplysia, which has shown promise in treating neurological disorders. Additionally, a compound derived from the marine sponge has been found to inhibit cancer cell growth. The pharmaceutical giant, Astellas Pharma, is currently researching these compounds for potential cancer treatments. According to a report from the National Oceanic and Atmospheric Administration, over 50% of new drugs in development are derived from natural products, many of which originate from our oceans. With the ocean covering over 70% of our planet, we are just scratching the surface of what lies beneath. Yet, as marine bioprospecting expands, ethical questions arise. How do we ensure that these resources are used sustainably? Will we find cures for debilitating diseases while simultaneously risking the extinction of valuable marine species? As we dive deeper into the ocean, we come face to face with a growing menace: microplastics. These tiny pieces of plastic, often less than 5 millimeters in size, are not only found on beaches or in surface waters. They have permeated even the most remote areas of our oceans, including the abyssal plains far below the waves. Microplastics originate from various sources: the fragmentation of larger plastic debris, the fibers shed from synthetic textiles during washing, and even the breakdown of industrial materials. Studies have shown that the concentration of microplastics can be alarmingly high in certain regions, with some areas reporting hundreds of thousands of particles in just a cubic meter of seawater. A crucial concern is the impact of these microplastics on marine life. Creatures from the tiniest zooplankton to the largest whales unknowingly ingest these particles, mistaking them for food. Research has indicated that microplastics can cause physical harm and toxicological effects in marine organisms. When these creatures consume microplastics, the pollutants can accumulate in their bodies, leading to bioaccumulation up the food chain. This poses a significant risk not just to marine ecosystems but also to human health as we rely on these ocean species for food. The infamous Great Pacific Garbage Patch serves as one of the most prominent examples of how plastic has infiltrated our oceans. Although many assume it consists solely of visible debris, studies reveal that the patch is also a hotspot for microplastics. To address this issue, scientists are racing against time to develop innovative solutions to monitor and reduce plastic pollution in the deep sea. Technologies like autonomous underwater vehicles, AUVs, are being deployed to survey ocean depths, while new filtration systems are being tested to capture microplastics in coastal regions. Efforts are also underway to educate the public about reducing plastic usage and improving waste management practices. In conclusion, while microplastics may seem like a small component of the vast ocean ecosystem, their impact is monumental, affecting marine life and, subsequently, human health. The journey to understanding and mitigating this threat continues, and it is imperative that we act swiftly, for the health of our oceans and ourselves hinges on it. Deep within the ocean, where sunlight barely penetrates, a spectacular phenomenon unfolds: bioluminescence. This natural light production, found in various marine organisms, creates a mesmerizing display that captivates scientists and explorers alike. From glowing jellyfish to sparkling plankton, bioluminescence serves multiple ecological purposes and reveals the extraordinary adaptations of life in the dark abyss. One of the most iconic bioluminescent organisms is the jellyfish. Species such as the Aquaria victoria are known for their ethereal glow, which can be attributed to a chemical reaction involving luciferin and luciferase. When disturbed, these gelatinous creatures can emit brilliant light, creating a stunning display in the dark waters. The glow serves as both a deterrent to predators and a form of communication, luring potential mates or prey. Moreover, bioluminescent organisms are not limited to jellyfish. The ocean is home to countless species displaying this extraordinary trait, including certain types of fish, plankton, and even bacteria. One fascinating example is the deep-sea anglerfish, which showcases a bioluminescent lure on its head to attract unsuspecting prey. Bioluminescence also plays a significant role in the ecosystem. For instance, the mesmerizing blue glow of certain plankton